Why is transient conduction important for engineers? Imagine a hot cup of coffee cooling down on your table. The heat doesn't leave instantly. It gradually moves from the hot liquid to the cooler air and surroundings. This process is a perfect example of transient conduction. It's the way heat moves through a material when the temperature is changing over time before settling into a steady state. Understanding this process is key for engineers because many real-world systems don't stay at constant temperatures. When a machine starts up, it heats up quickly, and the temperature inside changes constantly. Engineers need to know how fast these changes happen to prevent damage or failure. For example, in electronics, components heat up when they work, and if the heat isn't managed properly, devices can overheat and break down. Transient conduction also helps engineers design systems that are safe and reliable. When materials heat or cool, they expand or contract. Knowing how quickly these changes occur helps prevent cracks or other damage. For instance, in building construction, walls heat up during the day and cool down at night. Engineers use transient conduction principles to decide how thick insulation should be to keep indoor temperatures stable. Another reason transient conduction is important is for measuring material properties. Engineers use it to find out how well a material conducts heat or how much heat it can store. These properties are essential for choosing the right materials for different applications, like in heat exchangers or thermal insulation. Energy efficiency is another big factor. By understanding how heat moves during changes, engineers can design heating and cooling systems that use less energy. For example, they can create insulation that slows down heat loss during cold weather or helps heat stay inside during winter. Knowing how long it takes for a system to reach thermal equilibrium, or steady state, helps in planning operation cycles and maintenance. If you know how quickly a machine heats up or cools down, you can schedule operations to avoid overheating or wasting energy. In fields like automotive engineering, transient conduction analysis predicts how quickly an engine warms up when you start your car. In manufacturing, it helps control processes like welding, where temperature changes affect the strength and quality of the material. In building design, it models how walls respond to daily temperature swings, helping to create more comfortable indoor environments. All these examples show why transient conduction is so important for engineers. It gives a realistic picture of how heat moves when temperatures are changing, helping them design safer, more efficient, and longer-lasting systems.